Good afternoon, class. So at this point we're looking at the trig graphs. We're wrapping up the section on the general solution of the trig graph. We're on exercise 6.8. Okay. Did I ask you to do the whole exercise? Did I ask you to do the whole exercise? First column. Okay. How can it be this first column? The odd numbers. Sorry? Even. So we did all the odd numbers already. When did we do the odd numbers? Sorry? $6.8. Okay, 6.7 you had to do the even numbers. Yes. Any issues there? No. Okay. Then I asked you to do 6.8. Correct? And in 6.8 you had to do the odd numbers. The whole thing, no problem. Which page is this on? 211. Okay. So what I'm going to do is I'm going to do the odd numbers. So to give you a very good understanding of what's happening here. Okay. Just draw the curtains, please. Good. Alright. So let's look at number 1. Here we got sine of x is equal to the root of 2 over 2, where x is an element of these block brackets, so it's inclusive, negative 360 to 360. And we are told without the use of a calculator there. Why is it without the use of a calculator? Because this falls into special angles. Not so. So what we do is, we know this root 2 over 2, that comes from the 45-degree angle. There's 1, the root 2. We know that sine of 45 is 1 over root 2, which is the same as sine 45 is root 2 over 2. And they have rationalized the denominator. Okay. So what happens is, we know that this angle is 45 degrees. So my reference x is equal to 45 degrees. The question we ask ourselves, in which quadrant is sine? Positive. In which quadrant is sine positive? Quadrant 1 and 2. So let's go with quadrant 1. How do we get in quadrant 1? X is equal to 45 plus k times 360. Or in quadrant 2, how do you get into quadrant 2? 180, so x is equal to 180 minus 45 plus k times 360. 180 minus 45 is 135 plus k times 360. Where k is an element of integers. Okay. That's number 1. Let's look at number 3. Whoops, I'm forgetting something. They gave a restricted domain on the sum, not so. The restricted domain on the sum. We are told that x is an element of negative 360 to 360. So we start with k is equal to 0. Not so. So if I put 0 through here, I'm going to get 45, which is within that domain. If I put 1 in here, then I'm going to get 405, which is outside this given domain. If I put negative 1 in here, I'm going to get negative 315. If I'm going to put negative 2 in here, 45 plus negative 2 times 360 is way outside this lower boundary there. Then we put 0 in this equation, I get 135. Put 1 in is going to be over the upper boundary. Put minus 1 in, I get negative 225, just check if that's correct. 135 minus 360 is correct. If I put minus 2 in, it will be lower than the smaller boundary. Can you see that, people? So that is that answer there. Okay. Don't forget to list the values in which that occurs. Okay. Yes? Yeah, only when you're given, like here, you are given a restriction, so you have to list. If the restriction is not given, then you don't list. Okay. Like in number 3, we are asked to determine the general solution first. There's no restriction, so we stop. So we say 2 sine x minus 1, 4, 3, 1, 4, 3. So what we do first? Take it over, then divide by 2. So sine x equals 1, 4, 3 divided by 2. It gives me 0,715. So what we do now? Reference x, so we got arc sine of that answer. We have 45,4, 45,6 degrees. So what's the question you should be asking yourselves? In which quadrant is sine? Positive. So here's a positive here. Which quadrant is sine positive? First and second. How do we get into the first quadrant? Sorry? It's 1/8, it's a straight angle. So it's 45, 6 times k times, plus k times 360. Or quadrant 2. X is equal to 180. Remember, that's what we only work 180 plus, 180 minus, or 360 minus. Okay? There's 180 minus 45,6 plus k times 360. So x is equal to, what's 180 minus 45,6? 124,4, 134,4 plus k times 360, where k is an element of integers. And that's where we stop. And that's the general solution you asked. Okay? Let's look at number 5. Number 5. You got sine x plus 10 equals 0,932. So is the sine is the trigonometric ratio isolated? Yes. So I can go reference x plus 10 equals arc sine of 0,932. So 68,7. 68,7 degrees. So what's the question we should be asking ourselves? Which quadrant? Sine positive. So it's positive in 1 and 2. So let's go with quadrant 1. How do you get in quadrant 1? Is this the angle? So it's x plus 10 equals 68.7 plus k times 360. The 10 is over. So x equal to 58,7 plus k times 360 degrees. Or in quadrant 2. How do we get in quadrant 2? Is x plus 10 equals. How do we get into quadrant 2, people? 180 minus 68,7 plus k times 360. So x equal to what's 180 minus 68,7? Minus 10. Sorry? What? 111,3 plus k times 360. Where k is an element of integers. Remember, for that 108, you're subtracting that answer of 68,7 minus that 10 degrees. No? So 101,3. But remember, here's a restricted domain on number 5. So we start with saying x is an element of. We start by 0. You get 58,7. Not so? We'll put 1 in there. It's going to give you an answer over 720. 27. Say 270. We'll put negative 1 in. It's going to be lower than what is required. So 58.7 plus negative 1 times 360. That gives you negative 301,3, which is smaller than the lower boundary. Not so? So now I'm going to write that down. Let's go with this one here. I'll put 0 in. Definitely 101 is inside. 101,3. We're going to put 1 in by k. So it'll be outside. Let's try minus 1. 101.3 plus negative 1 times 360. That gives you negative 258,7. Is that inside or outside the given domain? Inside. Negative 258.7. There we go. Negative 2 will definitely be outside. Okay. Yes? You don't have to. We just mark on the branches. You see this here? This branch. We mark you there and there. The reason why I write it is because if the learner is a bit slow, they can see what I've written down and follow what I've written. Okay. Slowing is working now, you know? So yeah. Okay. Let's look at number 7. So you got 4 sine 4x plus 3 is equal to 0. Again, we're given a restricted domain. First thing is to isolate the trigonometric ratio. So you take 3 over, becomes minus 3 divided by 4. So sine 4x is equal to negative 3 over 4. Okay. We don't divide by 4 here, but we must first post the quadrant before we can touch that angle. So at this point, we're going to work out our reference. So our reference 4x is equal to arc sine of 3 over 4. But you notice I've dropped the negative. Okay. Yes.
Do you have to show that statement?
Sorry?
Do you have to show
the arc sine? No. You didn't see in all the other sums I didn't show it. So you didn't have to show it either. Okay. So the reason why I've written it in here was to highlight that I've dropped the negative sign. That's all I'm showing. So when you work this out, you say shift sign, arc sine of 3 over 4. That gives us an answer of 48,6. So you got 4x is equal to, the reference 4x is equal to 48,6 degrees. I don't again divide by 4. You leave the angle until you take it to its quadrant. The question you should be asking yourselves is in which quadrant is sine? Negative. So it's negative in 3 and 4. We go into quadrant 3. How do we get in quadrant 3? 4x is equal to 180 plus 48,6 plus k times 3. Why do you say k times 360? Because the period on the sine graph is 360 degrees. Alright, so we put that in our calculator. We say 48,6 plus 180 divided by 4 gives me 57,15. So x is equal to 57,15 plus k times. Remember now that was also divided by 4. K times 19. Remember it goes throughout. Or in quadrant 4, it's simply going to be 4x is equal to, how do you get in quadrant 4? 360 minus 48,6 plus k times 360. So that again becomes 360 minus 48.6 divided by 2. That gives you 155. Then divided by 2 divided by 4. This is 77,8. 5 that correct? Plus k times 90 degrees, where k is an element of integers. Do you all agree with that? Right, so restricted domain there. We must start off by saying, we start with k is equal to 0. So put 0 in here, we get 57, 1,5 or 57,2 degrees. Not so. If I put 1 in where you see 90, so it's 57,15 plus 1 times 360, no, 90. It's 147,15. Is that inside or outside? 147, 95 or 15? 15. What do you think what will happen if I put the 2 in by k? Will be outside the given domain. Not so? So let's try minus 1. It's going to give you negative 32,85. Let's put 2 in. Negative 122,85. That will be outside. Not so? So let's do the other branch. If I put 0 through there, of course I will get 77,85. That is inside. If I put so 77,85 plus 1 times 90. It gives you 167,85. Is that inside or outside? Inside, yes. There's 167,85 degrees. No? Then put minus 1. That's going to give us negative 12,15. Inside or outside? Inside. Negative 12,15 degrees. If I'm going to put minus 2 in there, definitely outside. This is negative 102 and the lower boundary is negative 90. Can you see that, people? So, I can close it here. Okay? And the last one, number 9. We are given negative sine 3x minus 2 is equal to 0. Take that over the equal sign, so it's negative sine 3x is equal to 2. Divided by 2 sine of x is equal to sine 3x is equal to minus 2. If you say arc sine of 2, it's going to give you no solution. Not so. So there's no solution on this side. Okay? Because if you look at it, if I draw the sine 3x graph, this is what the sine 3x graph looks like. No? That completes in 360 and so on. What is the maximum value on this graph here? Huh? 1. And here? Negative 1. Now if you're looking at, you must draw the graph y is equal to minus 2x. If that is minus 1, minus 2 is here. Can you see that? Which means to say this graph will never cut this line of minus 2. Can you see that, people? That is why it results in no solution. It's outside the range of this graph. That is why it will never be intersecting. That's why you don't get the solution. Okay? If I had put sine of 1 there, then I would have gotten an answer of 90. Can you see? But if the graph is not touching each other, then you won't get a solution. Make sense, people? Alright, that was 6.7. 8, sorry. The equation for the cos x equal to m graph. Same story. Okay. So what I'm going to do is, and do 3 examples before the end of this lesson, so to expose you to the cos graph. Okay. Two and two. Sorry about that. So it says use your calculator and try to determine the solution by the equation cos 2x is equal to a half, where x is an element of negative 360 to 360. So again, the cos graph, people, we need to isolate the trig ratio, not so. So we say the reference to x equals r cos of a half. Now we know it's a special angle. Now say we didn't know that. It's going to give us an angle of 60 degrees. Not so? You all agree with that? So, the question you should be asking yourselves in this case, in which quadrant is cos? Cos is positive. It's positive there, isn't it? Is that correct? No. It's all stations to clear one. First and foremost. So let's go with my girl. Leave her hand, please. So let's go with quadrant 1. How do you get into quadrant 1? 2x is equal to 60 plus k times 360. Then we divide by 2. So you get 30 degrees plus k times 180. 4. In quadrant 4. How do we get into quadrant 4? 360 minus. So 2x is equal to 360 minus 60 plus k times 360. So what's 360 minus 60? 300. Divided by 2? 150 plus k times 180. Where k is an element of integers. Now we have, yes? You want to see, instead of saying 2x here.
What? No, I want to say x instead of 2x.
You want to say 2x here? But what is the angle? The angle in question is 2x.
But I said the previous thing about the previous questions, 0.13,
Which one are you referring to? So the previous one we did was this exercise. Which one didn't we? Number 5. We said x plus 10.
Yes, sir. And then we said left x. We say left x plus 10.
I said reference x plus 10. So yeah, I did say reference x plus 10. Did I say reference x plus 10, people? Yes. I always say reference x plus 10. I keep the angle like it easier. So I don't want to get confused with it. Whatever angle is here, my girl, you write it as it is. At this point. Okay. So now we start off with saying x is an element of. And we go 0. Put 0 in, what do we get? 30 degrees. Put 1 in. I only get 210 degrees. Put 1 in. 180, that's 360, 390. It's outside. Not so? Put negative 1 in. I get negative 150. Put negative 2 in. Negative 330. You guys agree with that? Then, you put 0 in. There. 0 gives us 150. Then we put 1 in. That's 2 is 330. Put 3 in, 2 in will be outside. Put negative 1 in. Negative 30. Put negative 2 in. So it's 150 plus negative 2 times 180. It's negative 210. Okay, put negative 3 in, definitely outside. Okay. For homework, you see the only difference between exercise 6.8 and 6.9 is sign is positive in quadrant 1 and 2 and negative in those two quadrants. Not so. Whilst for the cos graph, or the cos ratio, is all stations to clear one. Cos is positive there and there, and is negative there and there. Okay? So it's positive in quadrant 1 and 4, and it's negative in quadrant 2 and 3. Okay? So for homework, I would like you guys to do exercise 6.9, you do for me the odd numbers. 6.9, the odd numbers. Then you do 6.10. 6.10 is dealing with a general solution for the tan graph. For the tan graph, we say k times 180y. So the period of the tan graph is 180. Then in tomorrow's lesson, I'll explain to you how you will see when we do the comparison of your answers, you will see that the one branch is not represented. I'll talk about that tomorrow. So you got 6.9 to do, odd numbers, and 6.10, the odd numbers as well. People enjoy the rest of your day. Good morning, good afternoon class.